Hello viewers, Renewable taking you through the story of O-level physics, and this video I'm going to go through the paper, the marking guide of senior 3 beginning of term exam of physics paper 1. So the question paper was already sent earlier on this platform, and I believe you have already attempted it, and now you're ready to mark yourself and check your progress. So these were the constants which would be used where necessary. So we shall start with question 1. Question 1 says that the energy which a body has by reason of its motion is. So the keyword here is motion. So this one is already off, and this one. So we have two words. We have two energies, potential energy and kinetic energy. Now potential energy is the energy which a body has by reason of its position. So if this word was position, then it would be, the answer would be potential energy. But now it is motion, meaning that this is not okay, and the only answer is kinetic energy. So shall come here and say that the correct option is option C. So that was question 1. Now we shall go to question 2. Question 2 says, which of the following is incorrect when the volume of a fixed mass of a gas is reduced at constant temperature? So we have 4 options. Option A is the pressure of the gas increases. Then option B, the number of molecules per unit volume increases. Then part C, or option C, the average speed of gas molecules increases. Then option D, the rate of collision of the gas molecules with the wall of the container increases. So here, if temperature is constant, it implies that volume and pressure are the ones which are varying, and in accordance with Boyle's law, when volume is reduced, pressure increases. Therefore this is okay. Now when you come here, the average speed of gas molecules increases. That is also okay, because when pressure increases, kinetic energy also increases. Then the rate of collision of the gas molecules with the wall of the container increases, because when speed increases, it implies that even momentum increases, therefore rate of collision increases. Therefore the only option which is not okay will be option B. Therefore you shall come and say that the correct answer is B. So that was question 2. Now we shall go to question 3. Question 3 says, a load of mass 200 newtons is raised through a distance of 2 meters using an effort of 100 newtons, which moves through a vertical distance of 8 meters. Calculate the efficiency of the system. Option A is 80, option B is 75, option C is 60, and option D is 50. So here what you should know is that this 200 is the load, and 2 meters is the load distance, 100 is the effort, and 8 meters is the effort distance. Therefore shall come and do some calculations to come up with the correct efficiency. So first of all, we shall remember that mechanical energy is load over effort. So load is 200, effort is 100, therefore mechanical advantage is 2. Velocity ratio is effort distance over load distance. Therefore effort distance was 8 meters, load distance was 2 meters, therefore when I divide, I'll come up with 4. Now that I have mechanical advantage and velocity ratio, I can come and say that efficiency is mechanical advantage over velocity ratio multiplied by 100. So mechanical advantage is 2, velocity ratio is 4, this 100 remains, so you come up with 50%. So in our options, I'll look for 50, and that will be the answer. So 50 is here, therefore the correct answer is option D. So that was question 3. Now we shall go to question 4. Question 4 says, The diagram shows a strip of paper tape that was being pulled, that has been pulled under a vibrating arm by an object moving at a constant speed. The arm was vibrating regularly, making 50 dots per second. What is the speed of the object? So option A is 2.0 centimeters per second, option B 5.0 centimeters per second, option C 100 centimeters per second, and option D 143 centimeters per second. So the first thing to do is to know that the distance between these dots is 20 centimeters. What about the number of dots? We have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, and we have 8. Therefore, capital N, which is the number of dots, is 8. Then we also have here that it makes 50 dots per second. That gives you your frequency. So we have frequency, we have the number of dots as 8, and we have the distance in between as 20 centimeters. Therefore, shall come and do some calculation here. So we know that speed is equal to distance AB over time taken from A to B. Distance AB is, we shall call it X, and time taken from A to B is this number of dots, the spaces between the dots over frequency. So the spaces, since the number of dots were 8, the spaces will be 7. That is why they will see n minus 1. So when I rearrange, make this one a product, this one becomes a reciprocal. That's why you see here fx over n minus 1. Therefore, I come and substitute for x, which was 20 centimeters, f, which was 50 dots per second, n, which was the number of dots, as 8 minus this 1 to get the spaces in between the dots. So when I use the calculator, I'll come up with this value, and this value, since our answers were rounded off, so I'll round off to whole number to give you 143 centimeters per second. So I'll go back and look for that option which has 143 centimeters per second. So that option is D. Therefore, I'll come and say that the correct answer is D. So that was question 4. Now we shall go to question 5. Question 5 says, when no external forces act on two bodies in a collision, the total momentum of bodies, part A, increases, part B, option B, decreases, option C, remains the same, remains constant, option D, is constant, is proportional to the product of their masses. Now, when there's no external force acting, it implies that total momentum is conserved. Therefore, it will not increase, it will not reduce, it is not proportional to the product of their masses, but it remains constant. In other words, total momentum before collision is equal to total momentum after collision. Therefore, it remains constant. So the correct option is option C. So that was question 5. Now we shall go to question 6. So question 6 says, which of the following is correct about diffusion? Option A, it takes, or in other words, diffusion takes place at the same rate in all states of matter. Option B, diffusion is faster in gases than in liquids. Option C, diffusion is faster in liquids than in gases. Option D, diffusion does not depend on temperature. So this is not okay, because when temperature increases, the rate of diffusion increases. Then diffusion is faster in liquids than gases. Remember, liquids are, it is gases which are widely spaced than liquids, so this is not okay. Then here, it takes place at the same rate in all states of matter. This is not okay, because in solids they are closely packed, the molecules, and in gases they are widely spaced. Therefore, it cannot be at the same rate. So the only option is this, because gases are widely spaced, therefore diffusion will be faster. So we shall come and conclude that the correct option is option B. So that was question 6. Now we shall go to question 7. Question 7 says, on the uncalibrated thermometer, the lower fixed point and the upper fixed point are 25 centimeters apart. So that is the fundamental interval. If the mercury level is a point 15 centimeters above the lower fixed point, the temperature indicated by the thermometer is. So this 15 is what we call the mercury thread and 25 is what we call the fundamental interval. So option A, 15 degrees Celsius, option B, 60 degrees Celsius, option C, 4 degrees Celsius, option D, 25 degrees Celsius. So we need to do some calculation to find out which is the correct answer. So you come and say that the temperature is given by this mercury thread, which is 15 over fundamental interval, which is 25 multiplied by 100 to come up with 60 degrees Celsius. So shall come and look for the option which has 60 degrees Celsius, and it's option B. Therefore we conclude that correct answer is B. So that was question 7. Now we shall go to question 8. Question 8 says, a body which produces its own light, now this word its own light, is known as option A, non-luminous, option B, luminous, option C, reflector, option D, natural. So this is not okay, this is not okay, and this is not okay. So the only option which is correct is option B. So we shall come and say correct answer is B. So that was question 8. Now we shall go to question 9, which says the principle of fluid pressure in hydraulic machines states that pressure is option A, the same at all levels in a fluid, and option B, pressure at a given depth is proportional, notice the word proportional, to the height of its fluid, and option C, transmitted equally throughout the liquid, and option D is due to the weight of the liquid above it. So because they said this word hydraulic machines and fluid pressure, it implies that it will be option C, which is transmitted equally throughout the liquid. So these ones are not okay for this principle. Therefore you come and conclude that option C is the correct answer. So that was question 9. Now we shall go to question 10. So question 10 says a body of mass 200 grams is acted upon by a force of 5 newtons. The acceleration of the body is option A, 25 meters per second squared, option B, 2.5 meters per second squared, option C, 0.25 meters per second squared, option D, 0.025 meters per second squared. So we need to do some calculations to find out the correct option. Therefore, here we know that mass is 200 grams, meaning it has to be converted to kilograms, and force is 5 newtons. So you come here and say that we know that F is equal to ma. So we come and substitute for F and for m. So this mass has been kilograms, that's why we divide by 1,000. So simplify and make A the subject. A will be 25 meters per second. Therefore shall come and look for the option which has 25 meters per second, and that option will be option A. Therefore the correct answer is A. So that was question 10. Now I shall go to question 11. A woman of mass 50 kilograms climbs 40 steps upstairs. If each step is 20 centimeters high, what is the potential energy gained? So option A, 4,000 joules, option B, 100 joules, option C, 400 joules, and option D, 20,000 joules. So we need to do some calculations. We know that the mass is this, and the height for each step is 20, but the number of steps are 40. Therefore, we have to first get the total height climbed. So total height moved will be 40 steps multiplied by the height of each step, which is 20 meters, but you have to convert it to meters to come up with 8 meters. Therefore, the potential energy is mgh. M is 50, g is 10 and it's a constant, and h is 8, which you have got here. Therefore, when I use the calculator for this, I'll come up with 4,000 joules. Therefore, I'll look for the option which has 4,000 joules, and that is option A. Therefore, A is the correct answer. So that was question 11. Now we shall go to question 12. When water spreads on a glass plate, the forces of attraction between water molecules and glass molecules are due to option A, surface tension, option B, adhesion, option C, viscosity, and option D, cohesion. So surface tension and these ones are already off because surface tension is tangential force acting normally per unit area. Viscosity is fluid friction. Therefore, we have option B and option D. Now, option B is the force of attraction between molecules of different kinds, and option and cohesion is force of attraction between molecules of the same kind. Therefore, here we have water molecules and glass molecules. So these ones are molecules of different kinds. Therefore, the correct option will be option B. So that was question 12. Now we shall go to question 13. Question 13 says a cuboid measures 16 centimeters by 2 centimeters by 4 centimeters. How many tubes of 2 centimeters can be fitted into the cuboid? Option A, 16, option B, 2, option C, 64, and option D, 8. So we need to do some calculation to come up with the correct option. So you come and say the number of tubes is equal to volume of the cuboid over volume of the tube. Volume of the cuboid is got by multiplying these sides, and volume of the tube, remember tube all sides are equal, therefore if we have one side then you have all the 3 sides, so it will be 2 times 2 times 2. So this gives you this gives you that, and when I divide I'll come up with 16. So I will look for the option which has 16, and that will be my answer. So that is option A. So shall come and say that correct answer is A. So that was question 13. Now shall go to question 14. Two forces of 24 newtons and 32 newtons act at right angles on a body of mass 2 kilograms. Calculate the acceleration of the body in meters per second squared. Option A is 10, option B is 40, option C is 20, and option D is 60. So we shall come here and say that first of all we need to get the resultant force. Since they are right angles, we shall use Pythagoras theory. Therefore F squared is equal to 24 squared plus 32 squared. Use a calculator. This gives you 576. This gives you 1024. When I add the two, I'll come up with 1600 and put square root on both sides to come up with F equal to 40 newtons. Therefore remember that F is equal to MA, so I'll substitute for F and for M and make A the subject, which will be 20 meters per second squared. So I'll go back and look for the option which has 20, and that is option C. So that was question 14. Now we shall go to question 15. A boxer, while training, notices that a punch bag is difficult to set in motion, and difficult to stop. Which property accounts for this observation? Option A is size, option B friction, option D is weight, and option C is inertia. So this is not okay, this is not okay, this is not okay, but the correct option is inertia, because inertia is the reluctancy of a body to start motion if it was originally at rest, or to start moving if it was originally, or to rest if it was originally in motion. So inertia says that if a body is in motion, it is reluctant to stop, and if it's also stationary, it is reluctant to start moving. Therefore this punching bag is difficult to set in motion and difficult to stop because of that property called inertia. So correct answer is answer D. So now shall go, that was question 15. Now shall go to question 16. The velocity ratio of a screw jack of Tommy bar of radius r and pitch h is given by the expression option A 2 pi r over h, option B r over h, and option C h over 2 pi r, and option D r squared over h squared. So let's see some derivation here of a screw jack. So that's the diagram of a screw jack, and this is the pitch. This is where the effort is. This is the radius of the handle, and this is the load. Therefore the distance between two successive threads is what we call the pitch. Therefore circumference, remember this one rotates, therefore the circumference of the handle will be 2 pi r, and therefore the distance moved by the effort is the circumference of the handle. Therefore effort distance is 2 pi r. What about distance moved by the load? Distance moved by the load is the pitch. I think you see this pitch is vertical and this load moves in a vertical motion, but this handle rotates in a circle. That is why this is circumference and this for the load is the pitch. Therefore velocity ratio is effort distance over load distance, and effort distance is 2 pi r, pitch is h. Therefore the correct option is 2 pi r over h. So we shall go and look for that option, and that is option A. Therefore A is the correct answer. So that was question 16. Now we shall go to question 17. A crane raises a mass of 500 kilograms upwards at a constant speed of 10 meters per second. Find the power developed. Note that they are using a speed of 10 meters. So we have the speed 10 meters per second and the mass of 500 kilograms. So we need to, so option A is 5.00 watts, option B is 50.0 watts, option C is 500 watts, and option D is 50,000 watts. So we need to do some calculation to come up with the correct option. So you come and say that power is equal to work done over time so taken. So work done is force times distance and time is t. But if I rearrange and put this one alone, I'll come up with force multiplied by distance over time. And know that distance over time is speed, which is velocity, and this force is the weight, which is mg. So I'll come and substitute for m, for g, and for v to come up with, use the calculator to come up with 50,000 watts. So I'll go and look for the option which has 50,000 watts. Therefore, the correct answer is D. So that was question 17. Now we shall go to question 18. The term temperature means, part A, heat, option A, heat absorbed by the substance, option B, source of heat to pass through a medium, option C, number showing the degree of hotness, and option D, heat disturbance through a material. So because of this word degree of hotness, it implies that that is the correct option. So this is not okay, this is not okay, and this is not okay. So the only option which is okay is that, because we know that temperature is a number showing the degree of hotness or coldness of on a given scale of an object. So the correct option is option C. So that was question 18. Now we shall go to question 19, which says, in a perfectly elastic collision. Note this word, perfectly elastic. Option A, only momentum is conserved. Option B, both momentum and kinetic energy are conserved. Option D, only kinetic energy is conserved. And option D, bodies move together after collision. So if here it was inelastic, it will imply that only momentum is conserved. So this is not okay. And here only kinetic energy is conserved. That is not okay, because and bodies move together after collision. So it is elastic, meaning that they separate. So this is also not okay. So the only option is that both momentum and kinetic energy are conserved. Therefore, the correct option is B. So that was question 19. Now we shall go to question 20, which says, a body started from rest, meaning initial velocity is 0, and accelerated at a rate of 8 meters per second. That is acceleration. Find the time it takes to cover a distance of 100 meters. So this is the distance, 100 meters. Option A is 25.0 seconds. Option B is 12.5 seconds. Option C is 5.0 seconds, and option D is 3.5 seconds. So we need to do some calculation to come up with the correct option. So from the second equation of motion, the distance was 100, initial velocity was 0, time is what we want, acceleration was 8, time is what we want. So 0 times t is 0, so it will come up with 100 equal to 40 squared. Divide both sides by 4 to come up with t squared equal to 25. Put square root on both sides to come up with t equal to 5 seconds. So we shall look for the option which has 5 seconds. And that is option C. So that was question 20. Now we shall go to 21. 21 says, the diagram below shows a manometer containing mercury of density 1.3 exponent 4 kilograms per meter cubed, connected to a gas supply. So this is the diagram. Calculate the pressure of the gas in pascals. Option 1, 1.1 exponent 5 pascals. Option 2, 2.3 exponent 5 pascals. Option C, 2.8 option exponent 5 pascals, and option D, 3.0 exponent 5 pascals. So you'll need to do some calculations to come up with the correct option. So here, there is atmospheric pressure, and here there is gas pressure. So this one will be equal to this atmospheric pressure plus this pressure difference, which is of height 5 centimeters. So shall come here and say that we know that atmospheric pressure is 76. We saw it in under the table of constants. That's atmospheric pressure is 76 centimeters of mercury, and the pressure difference is 5 centimeters of mercury. The density, but remember, because it's centimeters, we have to change to meters. That's why we divide by 100. Then density was given as 1.3 exponent 4, and G, acceleration due to gravity, is under the constant and 10 meters per second squared. So when I use a calculator, I'll come up with 1.053 exponent 5, but because they want the answer to 1 decimal point, I round off to 1 decimal point to come up with 1.1 exponent 5 pascals. So I'll go and look for the option which has 1.1 exponent 5 pascals, and that will be option A, which is our correct answer. So that was question 21. Now I shall go to question 22, which says that which of the following is true about friction? Roman 1, it causes, or friction causes, wearing of objects. Roman 2, friction can be reduced by oiling, by adding oil. Roman 4 or Roman 3, it is independent of normal reaction. So this is not okay because friction depends on normal reaction. It is only independent on the area of contact, actual area of contact. Therefore, that is not okay, but this is okay because it is true that friction causes wearing of objects, and this is also true because friction can be reduced by adding oil. Therefore, we shall look for option. This is not okay. So this is the one which is okay, Roman 1 and Roman 2. This is not okay, this is not okay. Therefore, the correct option is answer B. So that was question 22. Now I shall go to question 23, which says Branian motion shows that option A, force exists between the particles of matter. Then option B, particles of matter are arranged in a lattice. Then option C, particles of fluids are in continuous random motion. Option D, matter is made up of visible particles. So this word here is what will help us to know the correct option. So this is the correct option, and this is not okay, not okay, and not okay. Therefore, shall conclude that the answer is C. So that was question 23. Now I shall go to question 24, which says the diameter of a bicycle spoke can be best measured by using option A, micrometer screw gauge, option B, vernier caliper, option C, meter rule, option D, tape measure. So a bicycle spoke is very small, therefore it is option A, micrometer screw gauge, which can measure it more accurately. So this is not okay, this is not okay, and this is not okay. Therefore, the answer is A. So that was question 24. Now I shall go to question 25. Potential energy and kinetic energy constitute chemical energy, option A, option B, electrical energy, option C, solar energy, and option D, mechanical energy. So mechanical energy is the sum of potential energy and kinetic energy, so that is okay. This is not okay, this is not okay, and this is not okay. That implies that the correct answer is D. So that was question 25. Now we shall go to question 26. The figure above shows the portion of a water wave. Which points in the diagram are exactly one wavelength apart? Option A, P and R. So P and R, if you draw a straight line, that is not okay. It is inclined. Then option B, Q and S. Option C, Q and T, and option D, S and T. So P and R, we have already seen, is not okay. It is inclined. Then Q and S, it is not okay because that is just half wavelength. Then option C is Q and T. Q and T, that is okay because it is now one full wavelength. This is from here T is half, then from here T is another half to give you one wavelength. Option C, ST is not okay because ST is also half wavelength. Therefore, this is not okay, this is not okay, this is not okay, and this is okay. So we shall conclude that the correct answer is C. So that was question 26. Now we shall go to question 27, and it says a liquid in glass thermometer contains mercury. Which physical property of the mercury varies with temperature, enabling the thermometer to operate? Option A is mass, option B, melting point, option C, resistance, and option D, volume. So mass is not okay because we don't use a weighing scale to know the temperature. Then melting point is not okay, resistance is not okay because there's no electricity there involved. So the only option is volume because we can get the volume of that mercury. The readings depend on the volume. So the correct answer is D. So that was question 27. Now we shall go to question 28, and says which of the following sources of energy is non-renewable? Option A, petroleum. Option B, the sun. Option C, tidal waves. Option D is wind. Therefore, the one which is non-renewable will be petroleum. So the correct answer is A. So that was question 28. Now we shall go to question 29. So question 29 says, when a mass is hung from a spring balance and removed, the point on the spring balance does not return to the initial position. Does not return to the initial position because option A, the spring was too short. Option B, the extension of the spring was proportional to the mass. And option C, the spring stretched to proportional limit. Option D, the string extended beyond elastic limit. So it is elastic. When it does not return to its original position, it implies that it has undergone elastic deformation, so it has gone beyond the elastic limit. So this is the correct option, and these ones are not okay. So you can come and say that the correct answer is D. So that was question 29. Now we shall go to question 30. The system in the diagram below contains an incompressible liquid. A downward force is applied on piston K of area 40 cm squared. Determine the force of piston L. Option A, 1 Newton. Option B, 4 Newton. Option C, 80 Newton. Option D, 160 Newton. So incompressible liquid. meaning pressure will be the same. Therefore, we shall come and say that it's up to you. You can use the ratio of force over area, or use the ratio of force and equate it to the ratio of area. So if I use the ratio of force equating it to the ratio of area, I'll come and say that F1 over F2 is equal to A1 over A2. So I'll come and substitute F1 is what I want, F2 is 80, A1 is 2, A2 is 40. So I'll cross multiply by taking this one this side to come up with 2 over 40 multiplied by 80 to come up with the final answer as 4 newtons. So we'll look for the option which has 4 newtons as its answer. So that is option B, therefore the answer is B. So that was question 30. Now we shall go to question 31. Question 31 says, the diagram below shows a wheelbarrow and its load, which have a total load of 150 newtons. This is supported by a vertical force, capital F, at the ends of the handles. What is the value of F? So this should be value of F. Option A is 75 newtons, option B 150 newtons, option C 225 newtons, option D 300 newtons. So we need to do some calculations to come up with the correct option. So it's in equilibrium, so we shall take moments about the pivot, and that shows that when you take moments about the pivot, let's do this. We know that sum of clockwise is equal to sum of anti-clockwise. So about this pivot, this force is clockwise and this one is anti-clockwise. So for this one, the force will be this and perpendicular distance is 0.75. So it will be 150 times 0.75, and for this one it will be capital F multiplied by the whole of this from here to here, which is 0.75 plus 0.75. So that is where this line is coming from. That is where that line is coming from. So next is to simplify and make F the subject. F will be 75. So I'll go and look for the option which has 75, and therefore the correct answer is A. So that was question 31. Now I shall go to question 32. A bullet of mass 0.003 kilograms traveling at 10 meters per second squared per second penetrates deeply into a tree and is brought to rest in 0.01 seconds. Calculate the average retarding force exerted by the bullet. Option A is 30 newtons, option B 300 newtons, option C 3 newtons, option D 3000 newtons. So we need to do some calculation to come up with the correct option. So we know that force is equal to rate of change in momentum. So that means that F is equal to M in brackets V minus U over T. So M is this, V is 0 because it comes to rest, U is initial velocity which is 10, time is 0.01. So when I use a calculator to simplify this, I'll come up with negative 3 newtons. So that means that the retarding force is 3 newtons. So I'll go back and look for option which has 3, and that is our correct answer. So that was question 32. Now we shall go to question 33. The cooling fins at the back of a refrigerator are painted black because black bodies are Roman part A, good conductors of heat, part B, Option B, good reflectors of heat. Option C, good absorbers of heat. And option D, good radiators of heat. So the function of the cooling fins is to quickly remove the latent heat, or to radiate away latent heat. Therefore, the function or the property which is correct is this one, is that they are good radiators of heat, because their function is to radiate the latent heat. So this is okay, this is not okay, this is not okay, this is not okay for this case, for this cooling fins. Therefore, the correct option will be option D. So that was question 33. Now we shall go to question 34, which says, a student fails to unscrew the metallic lid of a glass pot of jam. He finds that the lid can be unscrewed easily when held under hot running water for a few seconds, as shown below. So as shown here. Why is it easier to unscrew the lid after running hot water over it? Option A, the air pressure in the glass pot falls. Option B, the glass expands. Option C, the jam melts. And option D, the lid expands and becomes loose. So the correct option, which is more okay, is this one, that the lid expands, because metals expand when heated. So this is not okay, this is not okay, this is not okay, and this is okay. So the correct answer is D. So that was question 34. Now shall go to question 35. It says, the diagrams below show cross sections of different drinking glasses. Which one is the least stable when full with a liquid? So first of all, stability depends on also what is supporting. So if you look at these supports, this is the widest, so it is more stable, but they want the one which is least stable, so this is not okay. And also this, if you compare this, and this, these two are of the same size, but these ones are bigger. So this is not okay, this is not okay, because they are a little wider, the area. So we shall come to these two which have the same size, which is supports them, but now what will differ will be the position of the center of gravity. So if you look at this, the center is at that point roughly, and for this one, let's say the center is at that point. So you realize that this one is more, option B is more raised, the center of gravity is more raised than option A. What does that mean? It means that the higher the center of gravity from the ground, the more unstable. Therefore, option B is more unstable than option C. And than option A. In that case, we shall say that this one is also less, not the least stable, and this will be the least stable. Therefore, we shall come and say that the correct answer is B. So that was question 35. Now we shall go to question 36. The figure below shows the strip at room temperature and when cooled below room temperature. That is the strip at room temperature, and this one below room temperature. The change in shape occurs because option A, brass contracts more than invar. Option B, brass expands when it cools down. Option C, brass and invar and brass contract by equal amounts. Option D, invar contracts more than brass. So contracting means that the size becomes smaller. So if you look at this, it is brass which has contracted, so its size has become smaller. Therefore, this option that invar contracts more than brass is not okay. Then invar and brass contract by equal amounts, that is not okay, because if it was true, the strip would have remained straight. Then brass expands when it cools down. So that is not okay, because in this case brass has contracted. So the only correct option is option A. Therefore the answer is A. So that was question 36. Now we shall go to question 37, and says, a shoe shop puts a mirror on the wall so that customers can look at their shoes. The length of the mirror is 50 centimeters. A customer has eyes 150 centimeters above the ground level as shown. The bottom of the mirror is at a height of h above the ground. What is the smallest value of h that allows the customer to see an image of his or her shoes? Option A is 0 centimeters. Option B is 25 centimeters. Option C is 50 centimeters. Option D is 75 centimeters. So we need to draw some red diagram to easily come up with the correct value of the height. So you come here and first redraw what was given. Then we shall start drawing the red diagrams. First of all, we know that object distance is equal to image distance. Therefore, if from here to here, this distance from here to here is some distance from here up to here, so, and we know that the image is virtual, so we shall redraw the image which is virtual and laterally inverted. So virtual is drawn by dotted lines, so that's why the image has dotted lines. So this is distance x, this is also be distance x. But remember, I want to see the feet of my shoe, so this eye must be able to see this shoe. Therefore, I'll come and draw a red diagram which goes up to the shoe. I think you see that I'm using a ruler to draw from here the eye up to the shoe, because the eye has to see the shoe. So angle of refraction, angle of incidence is equal to angle of refraction. That is why if this is theta, this will also be theta, alternating angles, and if this is theta, this will also be equal to theta, because I is equal to r. Now from there, I realize that this is an isosceles triangle where these sides are equal. If they are equal, it means that this line bisects this side into two. Therefore, if the whole of this from here to here was 150, it implies that from here to here is a half of 150, which is 75, and also from here to here is a half, which is 75. Therefore, the value of h, least value of h, should be 75 centimeters. So I'll go and look for the option which has 75 centimeters, and therefore the answer is D. So that was question 37. Now I shall go to question 38. 38 says, calculate the volume at STP, standard temperature and pressure, of a gas whose volume is 100 centimeters cubed at a temperature of negative, know this word, negative 25 degrees Celsius, and pressure of 746 millimeters of mercury. Option A is 1.08 centimeters cubed. Option B, 10.8 centimeters cubed. Option C, 108 centimeters cubed. And option D, 1080 centimeters cubed. So we need to do some calculations to come up with the correct option. So before you use the gas law equations, you have to first change to the temperature to Kelvin. So negative 25 degrees Celsius to Kelvin is got by adding 273 to come up with 248 Kelvin. Therefore, I'll come and use the gas equation, ideal gas equation, for the P1 V1 over T1 is equal to P2 V2 over T2. Therefore, the given pressure was 746, volume was 100, temperature has been got as 248 Kelvin. Then at STP, pressure is 760 and temperature is 273, volume is what we want. So my aim is to make V the subject. So what I'm going to do, I'll take this one this side to come up with this times that. Then take this one this side to come up with this times that. Now when I use a calculator, this will give me 108.05, but I want a whole number, so it will be 108 centimeters cubed. So I'll go and look for the option which has 108 centimeters cubed, and that would be the answer. So that was question 38. Now we shall go to question 39. When a yellow dress with blue dots, know this word, yellow dress and blue dots, is placed in a room lit with pure red light, the dress appears, option A, red with black dots, option B, yellow with blue dots, option C, red with cyan dots, and option D, red with magenta dots. So there's something we need to know about this. So what you need to know is that this one is a secondary color got by mixing red and green, and blue is a primary color, and also red is a primary color. So what does that imply? So shall come here and say that there's something we need to know is that when a secondary color of an object is in a given primary color of light and the two colors are not complementary, the object reflects and transmits that particular primary color into the eyes of the observer and absorbs none. So what does that mean? It means that secondary color plus primary color will give you that primary color. So in this case, yellow is a secondary color and it has two colors, which is red and green. And this red is a primary color, and this primary color is within this secondary color. So that means that the output or the appearance will be that primary color, which is red. That means that the yellow dress will appear red. What about the blue dots? So for the blue dots, what we need to know is that when a primary color of an object is in a different primary color of light, it appears black. So that means that primary color plus primary color will give you black color. So these blue dots where blue is the primary color and red is the primary color. So when you mix the two, the outcome will be a black appearance. So what does that mean? It means that the blue dots will appear black and the yellow dress will appear red. So let's go and see the correct option. So the one which has red and black dots is the correct option, and that is option A. So that was question 39. Now we shall go to question 40. A steel paper clip is attached to a string which is fixed as shown below by a piece of thread. The clip remains suspended beneath a magnet. As the magnet is lifted, the paper clip begins to fall as a result of option A, increase in the potential energy of the magnet, option B, increase in potential energy of the clip, option C. Increase in the weight of the clip, option D. Decrease in the magnetic field strength near the clip. So this potential energy means that this option is not okay, and this one is also not okay. Then increase in weight of the clip, the weight does not increase. So weight changes with height, with altitude, but now this one it will not, so because they're in the same place. So then option D, decrease in magnetic field strength near the clip. So that is okay, because when this one is lifted, is taken out further away from this clip, the magnetic field strength will keep on reducing. So this is not okay, not okay, not okay, and this one is okay. So the answer will be D. So that was section A. Now we shall go to section B, which is structure. So section A is objectives and section B is structured. So question 41, part A says, define the term amplitude of a wave. So you come and say that amplitude is the maximum displacement, so this S is not there, of an oscillating wave particle from its rest position or equilibrium position. So that is 1 mark. Then part B, they give you this diagram, and let's see the question. The question says, the figure above shows the variation of displacement with time of an oscillating particle. Determine Roman 1, the amplitude of the particle, Roman 2, the frequency of the particle. So the amplitude is from here up to here, so the maximum displacement is 0.2. Therefore you come here and say that amplitude is equal to 0.2 meters. Then frequency, for frequency you have to first know the period. Now period is one complete oscillation from here up to here, and that time is 0.04 seconds. Then from there we shall know that frequency is the reciprocal of period, which is 1 over 0.04 to give you 25 Hz. So 1 mark for stating amplitude, half a mark for getting period, half a mark for formula, half a mark for substitution, half a mark for the frequency. So that was question 42. Now we shall go to question 43. Part A says, what is meant by a first class lever of a machine? So you come and say that this is a lever system where the pivot or fulcrum is between the load and the effort. So when the pivot is between the load and the pivot, it is first class lever. Then part B, a machine uses an effort of 50 newtons to move a load of 200 newtons through a distance of 4 meters. If the effort moves a distance of 32 meters, calculate the Roman 1 velocity ratio. So we know that velocity ratio is effort distance over load distance. So the effort distance will be 32 meters and load distance will be 4 meters. Therefore when I divide, I'll come up with 8. So that will be the velocity ratio required. So 1 mark for the definition of first class lever, half a mark for the substitution, half a mark for the output. Then Roman 2, they wanted the efficiency of the machine. So now that efficiency is equal to mechanical advantage over velocity ratio multiplied by 100. So the first thing to do is to get the mechanical advantage, which is load over effort, to give you 4 as mechanical advantage. And we already got the velocity ratio, so we shall come and substitute mechanical advantage, velocity ratio, and this 100 to come up with 50%. So half a mark for mechanical advantage, half a mark for this formula, half a mark for the substitution, half a mark for the output or the efficiency. So that was question 42. Now we shall go to question 43. 43 part A says, define the terms cohesion and adhesion. So you say that cohesion is the force of attraction between molecules of the same substance or same kind. So the keyword here is same. What about adhesion? Adhesion is the force of attraction between molecules of different substances or different kinds. So the keyword here is different. Then part B, a drop of olive oil of volume 0.1 millimeters cubed is placed on the surface of clean water. It spreads out completely into a patch of area 100 centimeters squared. Calculate the thickness, Roman 1, calculate the thickness of the oil patch. So now that thickness is equal to volume of the oil drop over area of the oil patch. So volume was this one, but you have to convert to meters cubed by multiplying by 10 to the power negative 3. And this area, centimeters squared, so that has to be converted to meters squared. And that is by multiplying it by 10 to the power negative 2. So when I divide the two, I'll come up with the thickness as 1 exponent negative 4 centimeters. So 1 mark for definition for cohesion and 1 mark for definition of adhesion. Full mark for this substitution and full mark for this output with the correct unit. So that is B Roman 1. What about B Roman 2? So B Roman 2 says, state any one assumption made in this experiment. So the assumption is that the oil patch formed is 1 molecule thick, and that is 1 mark. So that was question 43. Now we shall go to question 44. Part A says, what is meant by evaporation? So here we shall come and say that evaporation is the process by which a liquid changes to gaseous state at any temperature. Know this word, any temperature. Then give two differences between evaporation and boiling. So the first one is boiling takes place at a fixed temperature called boiling point. So this here there was a word boiling point, here boiling point, while evaporation occurs at any temperature. So you remember to add here the word point to make boiling point. Then the second difference is that boiling takes place throughout the liquid, while evaporation takes place only on the surface of the liquid. Then next is that boiling does not result into cooling, while evaporation results into cooling. The next we shall say that boiling is a vigorous process, while evaporation is a gentle process. The next we shall say that bubbles are formed within the liquid during boiling, whereas no bubble is formed on the surface of the liquid during evaporation. So here 1 mark for this definition of evaporation, and here any two differences you get yourself these 2 marks. So part C, explain why it takes longer to cook food at the top of a mountain. First we need to remember that boiling occurs when its saturated vapor pressure is equal to the external atmospheric pressure. And we also need to know that atmospheric pressure is low at high altitude. So what does that mean? It means that when one cooks food from the top of a mountain, saturated vapor pressure will be equal to atmospheric pressure at a lower temperature. And in that case, we have come and said that due to a low boiling point, water will vaporize. Low boiling point because it boils at lower temperature. So water will vaporize before food is well ready or properly cooked, hence taking a longer time for food to be ready or fully cooked. So that's how the mass can be distributed. So that was question 44. Now we shall go to question 45. So part A says, define the term pressure. So you come and say that pressure is the force acting normally per square meter. Then part B, a wooden block of mass 50 kilograms measuring 5 meters by 4 meters by 2 meters is resting on a table. Calculate the maximum pressure it exerts on the table. So maximum pressure, we use the smallest area. So of these three, you look at two, you get the two which are smaller. The smallest ones are 2 and 4. That's why the area is 2 times 4, and that will be the minimum area. Then the force will be the weight. So mass is 50 multiplied by G, which is 10. So when I divide, I'll come up with 62.5 newtons per meter squared. And that will be the answer. So 1 mark for the definition of pressure, half a mark for the formula of pressure, half a mark for you to get this weight, half a mark for you to get the smallest area, and half a mark for dividing the two, and full mark for getting the output with the correct unit. So that was question 45. Now we shall go to question 46. Part A says, define the term uniform acceleration. So uniform acceleration is the constant rate of increase of velocity with time. So this is increase because they said acceleration. If they had said deceleration, here I would have used decrease. But because they have said acceleration, here we have to say increase. Then part B, a cyclist of mass 80 kilograms is moving with a velocity of 50 meters per second and then applies the brakes to reduce the velocity to 10 meters per second in 8 seconds. Determine the force applied to reduce the velocity of the cyclist to 10 meters per second. So we have initial velocity as 50, final velocity as 10, and time taken as 8. Our aim is to get acceleration. Therefore, we shall use the first equation of motion and substitute for final velocity, initial velocity, and time to remain with A as the only unknown. So simplify, take this 50 this side to come up with 10 minus 50, which is negative 40, and A times 8 is 8A. So make A the subject, A will be negative 5 meters per second squared. So now that I got A and I know the mass, I remember that force is equal to ma. Therefore, mass is 80, A is negative 5, to come up with negative 400 newtons. Therefore, the force applied is 400 newtons. So, full mark for definition of uniform acceleration, half a mark for this substitution, half a mark for output, half a mark for the formula, half a mark for substitution, half a mark for output. So that means that you can either stop here at negative 400 or you conclude any is okay. So that was question 46. Now we shall go to question 47. Part A says, define potential energy. So you are coming and say that this is the energy possessed by a body due to its position or state in a field of force. Then part B, a car of mass 800 kilograms moves along a straight road with a speed of 72 kilometers per hour. Calculate the kinetic energy of the car. So the first thing to do is to convert from kilometers per hour to meters per second by multiplying by 1000 and dividing by 3600. When I use a calculator, the whole of this will be equal to 20 meters per second. So after converting, I can now code the formula and substitute and get the answer. So the mass is 800 kilograms and the velocity is 20, but it is squared, that's why there is a square here. So the whole of this, using a calculator, it will be 160,000 joules. So 1 mark for the definition of potential energy, half a mark for converting from kilometers per hour to meters per second, and half a mark for the output after using a calculator. Half a mark for quoting the formula for kinetic energy, half a mark for substituting, full mark for output with correct unit. So that was question 47. Now we shall go to question 48, and part A says state Snell's law. So Snell's law states that the ratio, so this is not ratio, so you remove this n. So it says that the ratio of sine of angle of incidence to sine of angle of refraction is constant for a given pair of media. So in part B we have this diagram, and let's see the questions being asked. So the figure above shows a ray of light traveling from air into a glass block. Determine the refractive index of the glass block. So the first thing to do is to get the angle of incidence, because angle of incidence is measured from the normal, but this one is to the horizontal. So we have to first get this angle, and that angle will be 90 minus 30, which is 60 degrees. The next is to, now I've got the angle of incidence and I have the angle of refraction as 35 degrees. So I'll come and substitute in the formula for refractive index. So sin I is 60, R is 35. So the whole of this using calculator will give me 1.51. So half a mark for angle of incidence, half a mark for quoting the formula, half full mark for substitution, both numerator and denominator, full mark for output. So that was question 48. Now we shall go to question 49. Part A says, state the fundamental law of magnetism. So the law states that unlike poles attract while like poles repel. Then part B says, why does a freely suspended bar magnet always rest approximately in the north-south direction? So first we shall write that the resultant Earth's magnetic field lines run approximately from geographic south to geographic north. So what does that mean? It means that a freely suspended magnet settles with unlike poles attracting, hence it points in north-south direction. So south, unlike poles for this south, it will be north. Unlike pole for north will be south. That's why it is north-south. So that's how the marks could be distributed. Then part C says, state one usefulness of the Earth's magnetic field to man. So one, we can say that is used to indicate directions of places. And two, we can say that it is used to shield life on Earth from charged particles that originate from space, or to divert charged particles away from the Earth, and of the two. Then now shall go, that was question 49, now shall go to question 50, and part A says, what is meant by dispersion of light? So you come and say that dispersion of white light is the splitting of white light into its component colors according to wavelength. So now shall go to part B. Part B says a ray of yellow light is directed into a prism as follows. So complete that ray diagram. So what you should know is that yellow is a secondary color and it goes from red and green. Therefore, when it goes through the prism, it will split into red and green. So that is green, and next is red. So 1 mark for the definition, half a mark for this green, half a mark for this red. So you don't interchange because of the wavelengths. Then part C, explain why a green leaf appears green and feels warm in sunlight. So first, it appears green because it reflects green light. So that is appearance. What about the warmth? So for the warmth, we shall say that it feels warm in sunlight because it absorbs other colors of light, and the energy of the absorbed colors increases the internal energy of the leaf. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be for the marking guide of physics paper 2. So I believe you have already tried it out, and in shortly we shall release the marking guide so that you also mark yourself and check your progress in physics paper 2 of senior 3 beginning of term 3. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on solutions of physics paper 2 senior 3 has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family.